Hello everyone, I am Prabhu Reddy from Sri Venkateswara College of Engineering from Department of Electronics and Communication and Engineering. To video subject is Computer Organization and Architecture. The subject code is BEC306C. In this video we are gonna learn about 2's complement of binary numbers and their representation with respect to 32-bit configuration and 64-bit configuration. The first one is 2's complement. If there is any number given to find out its 2 complement, there is a formula 2 to the power n minus the number, that is capital N. If the number is not equal to 0, then we can find the complement. If the number is equals to 0, the complement is 0. Using the same formula 2 to the power n minus the number n, there are two examples given in this slide. The first one is 2's complement of 101100. Then the next step is 2 to the power 6. 6 is nothing but the number of digits or the number of units in the given number minus 101100 to the base 2. It's nothing but the number, the given number itself. In the same way, we have to find out the 2's complement for the another example also. Then comes the 32-bit point representation of the given number and its complement. The 32-bit configuration is divided into 3 parts. The first is sign bit, that is plus or negative sign of the given number. And then is biased exponent. It is represented usually in the form of 2 to the power. And then comes the third part, that is mantissa. Mantissa is the numbers that come after the decimal point in the given number. Let's see some example. Here we have been given a decimal number 45.45 to the base 10. First we have to convert it to the power 2. Then recognize its mantissa and normalize the mantissa by adding 1 and again use the bit exponent bias formula, that is 2 to the power n minus 1 whole minus 1. This is the representation of converting a decimal number to a binary number. The first table denotes the conversion of 45 before the decimal point. The second table or the long table represents the conversion of numbers after the decimal point, that is 4, 5. Then after we convert it into decimal, shift all the decimal points so that there is only one point to the left of the decimal point. It's easy to recognize the mantissa in this way. And then take the bias exponent, that is E equals 5 plus 125, 127. This is a formula where 5 is the power or exponential raised. Then the mantissa is the right side of the converted binary decimal. Then take the exponent, bias exponent, that is 132, which was represented as 127 plus 5 in the previous slide. convert it into the binary, and you can write it in the second part, that is bias exponent part. And you can represent the mantissa in the third block, which is of 23 bit. Here in the first block it is 1 bit because it is 0. If it was 1, the sign would have been minus. Here comes the 64-bit representation of a number. It goes same, the procedure is same as the 32-bit, but there is a small change of division of the three parts. The first bit is as usual sign bit for 1 bits. Here the biased exponent expands to 11 bits, and mantissa part also grows to 52 bits, and bias value also increases over here. The same number is taken as example for 64-bit representation also, for easiness or convenience. Here also first we have to convert it into binary and then take its exponent value, that is 5 plus. There in the 32-bit it was 5 plus 127. Here it is 5 plus 1023. Here also 5 denotes the power raised to 2. It's 1028. You have to convert your 1028 into binary again, and that number is represented in the 11-bit part or bias exponent part. Then you have to even recognize the mantissa part that I have already mentioned. You have the mantissa part is the right part or right side of the decimal points, the numbers which lie on the right side of decimal points. Write the mantissa in the third block where it's 52 bits, and in the first block it is 0 because because the number is positive. I hope you understood the topics. Here our video comes to an end. Thank you for watching the video. Please like, share and subscribe to my channel.